guys and gals. Hey, guys and gals. Parents, students, appreciate you being here. Thank you for hitting that play button. Turn it up. Turn it up. I love it. You know I love it. Let's go. You beautiful, intelligent people. Here to learn, here to learn. Let's go. Quickly going to check the stream. Make sure we are golden. Golden like Freddy. You beautiful, intelligent. Yes, we are. Let's go. Turn it up. Okay. Awesome sauce. We're going to get right into it, guys, and gals, because like usual, time flies when you're having fun. This is for you parents that are homeschooling your children. Maybe you need additional extra help and support. I don't know, but here I am doing it for you. If you need it, you are welcome to be here. Students alike as well. Maybe you have a not so great teacher that doesn't teach what the teacher is supposed to teach type teacher. Maybe you have one of those. I don't want to go on a tangent about that, but maybe you do, and you're on searching YouTube looking for additional support because you actually want to do well. That is awesome of you. I support you 100%. I love it. If you have that kind of thinking, thought processes, man, you are awesome. You truly are. Okay, right. Yeah, that makes you strong, in my opinion. Right? Yeah. Okay, we'll leave it at that, though. Okay. We got to stay on topic. Yeah, it's just an area. Yeah. So I'm here to support you parents and you students alike. If you need extra support, I'm here to help. If you have any questions, anything related to mathematics, just let me know. Again, I could go on and on about my resume. I could. But let's just say I am qualified. And I will do my best to stay on topic and just talk about mathematics. Okay? Awesome. Yeah, so if you have a specific area that you are kind of working on, need extra support or help in, let me know in comments below, and I'll do a video just for you. Let's go. Okay, so, but yeah, I'm going to try to follow the curriculum as well, so I'm kind of trying to push out a lot of videos right now, kind of catch up to the system or to catch up to where you guys are right now. So, and the good thing about it, I'm doing this right now, hopefully to help you prepare for your finals. You're gonna bust it. You're gonna be awesome. You're gonna just ace it. You are. I believe in you. Okay, let's get going. All right, so we kind of went over the key terms quickly. I just drew in some shapes here. You know, that's showing the area. So when you're calculating area, that's the surface that we're talking about. Again, this is all two-dimensional, so we're looking at a 2D plane. Okay? Rectangle, square, two squares make a rectangle. Apparently a square is a rectangle. Apparently. Things you learn. Okay? Even words like constituent. Constituency? Constituent. I could spell it. I just can't say it. And again, we have a isosceles. I even had to kind of refresh my memory. I drew it as an isosceles, I guess. No. Let's have a look. There it is. Look at me. Yes, isosceles. I did. All right, where am I here? So, two right triangles will actually make that shape. They're just mirror images of each other. And so that's all I have, because I'm going to kind of work off a sheet myself. I didn't want to really scan it all, guys, but I will do my best to draw images and pictures and such here for you guys and gals. Okay, of course I don't have a ruler to do it all, so we're just gonna have to make the best of it. Okay, let's talk about we're gonna talk about, remember we were talking about composite shapes. And then I was talking about, man, what was that terminology again that they used? Units, square units, right? So a lot of times you're going to see, let's see if I could find something kind of, let's see. I kind of cleared my search history. Area of, the definition of area. I think it was of area, or no, let's go rectangle in mathematics, something to that effect. Let's see if I can find, so they do this other thing, which I guess you can, if I can find an image here, I'll share with you what I'm thinking. Here we go. This is it. Okay. Right here. So as you can see, there's like 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of like looking at the top surface of a Rubik's Cube. And then, of course, you have multiple shapes creating a shape, right? So that's kind of what I wanted to show you. So they were explaining square units. So if we counted this as like 1, 2, 3, that would be 3. 3 squares. Of course, I don't want to confuse you guys here. That wouldn't work out because that should be 8. But square units is kind of what they're referring to when you actually do the math. It would be a square unit. So here we actually have the units M, which refers to meters. So that's kind of what I wanted to talk about. It's nothing really too critical. You just need to understand that if they're saying square units, well, you don't have any base units given, such as inches or feet or meters or I don't know, bologna sandwiches. It's just square units, right? That's it. Okay. All right. Let's carry on. So, let's see. I guess we'll do one for example. Okay, I'm gonna try my best to draw a square, guys and gals. Let's just pretend that they are perfectly square lines, perfectly drawn shapes. So we're talking about perimeter, right? So let's say, I don't know, this is 4. Okay. As a matter of fact, I should do it like this. Whoops, let's do it like this. Four and 4. Okay. And then, of course, you know, it should be the same on the other side as well. Go back to my old drafting skills here a little bit. And I can't really draw an 8 sideways. I'm going to try. Whoops. Probably should maybe avoid that. Okay, there we go. So that, you know, lets us know that it's a perfect square. So if we're going to calculate the perimeter, remember, recall if you watched the last video, perimeter is kind of like, let's say this is a sidewalk, okay? Again, this is supposed to be a perfect square. Let's see if I can clean it up a little bit, guys. Okay. All right, so that's good enough. Okay, so imagine you're a person and you're walking on your lunch break or whatever, and you walked this whole perimeter. That's essentially what it is. So it's the total distance that you walked, essentially. That's the perimeter. So if you add this side, plus this side, plus this side, plus this side, which would be 8 times 4, which is 32. So in our case, our perimeter is going to equal 32. We don't have any units, so we could assume that it's going to be 32 units, right? Kind of like I was saying earlier. Well, no, I guess it wouldn't be units because, I don't know. Sure, we don't have any units, so I don't want to it's just really not necessary. We don't have any units. We could pretend it's centimeters. We could pretend it's inches. We could pretend it's whatever we want. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. When they talk about units, what they're referring to is like this distance here is a unit. Okay, so if you count 1, 2, 3, 4, 5, 6, 7, 8, you would technically have 8 units. I don't know why they do that, but I mean, it is the perimeter, I guess. But our perimeter isn't 8 units, it's 1, 2, 3, 4, 5, 6, 7, 8 times 4, which is 32. So times 4, so that would be 32 units if we called this a unit. Okay, again, we can call it centimeters, we can call it inches, we can call it whatever we want. We could call it bologna sandwiches if bologna sandwiches was a measuring unit. Okay, and then the area equals, right? It doesn't really matter. With a square, you can call it side squared, which is one side, which would be 8 squared. Now we're kind of getting into exponents a little bit, guys. Okay, so squared, all that means, guys and gals, we'll talk about it more, but all it means is this. Actually, I'm going to do it like this. That's all it means. Same number times the same number. Okay, that's all squared means. If you see cubed, it would be, cubed would be 8 times 8 times 8. Okay, that's cubed. All right, makes sense? We'll go over it again. What? That's all it means. Okay, so, but if it's a rectangle, So if that's perfect if it's a square. But if it's a rectangle, you're going to be using the formula length times width. Okay, in this case, we're just going to pretend we obviously don't have a rectangle drawn, so I guess I should draw one just so that we have something. I'm going to go like this, like this, like this, like that, and like that. I'm going to call this, I don't know, I had 32 on in my brain, so we're just going to do that. It's not perfect, but you know what it is. And we'll just call this 8 again. Okay, for example. Of course, I'm not going to draw all the units because we would have 32. Again, the area refers to this. Okay, I don't want to draw all that, looks too messy, but that's what we're looking at right there. Okay, so in this case, we're going to be going length, which is 32, because length is usually the longest, times 8. Okay, we don't really need to do the math. I can, I guess. Be quicker on my calculator, but it's just 8 times 2 is 16. Carry the 1. 8 times 3, 24, 25. 256. And that would be square units, or units squared, whatever we want to call it. Right? The reason it's squared is because we multiplied a unit times a unit, if that makes any sense. Double check my work. 32 times 8, 256. Okay, and in this case, 8 squared is 64. Now, I don't know, maybe they teach you units or whatever. Maybe this is the way they teach you. I don't know why. To me, it seems like it's overcomplicating things. But I'd like to try to, not have it so complicated for you guys, right? The goal is to not make it complicated. So 8 squared is 64. Okay? And technically speaking, you could still calculate the area of one piece, right? You could calculate all this area and then just multiply it by 4. So this would be 4. 4 squared equals 16. And then because there's 1, 2, 3, 4 of them, you could go 16 times 4. I'll show you the work. 6 times 4 is 24. Carry the 2. 4 times 1, 4. Plus 2, 6. Okay? So, it's however you want to do it. That's area in a nutshell. Really, we don't need to do so many examples because I just want to see what up. Oh, okay, there we go. We'll just leave that for now. Okay. So they'll have like a lot of homework or practice examples. You'll have different shapes. 1, 2, 3, 4. I almost wish that I could use like a ruler type thing on this program. If I zoom into like the actual, but of course I am 32 pixels here, so you can draw straight lines that way, but I'm zoomed out, so it's not as easy. I don't have anything that'll kind of snap. So, all right, so in this case, we would have, you would count the sides, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be 10 units. I don't know why they teach it this way. This is not the way I learned. For me, that's overcomplicating. And you have 4 square units. So you can see this is 1, 2, 3, 4. So in other words, you have 4 square units. Maybe they're just trying to get you used to the different shapes and such. I don't know. Again, the goal is to we're kind of working towards composite. Whoops. Where is that? See if I can find that again. Right? Composite shapes and working with composite shapes, right? Okay. So, and then they'll try to trick you too with some weird shapes. So, you know, it's kind of like Tetris, guys, right? I'm just going to kind of try to draw a Tetris shape. Right? That would be one shape, but you could turn it into a composite shape, right? So now we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units, right? Really, you're just counting the sides. Nothing too top secret about that. 1, 2, 3, 4 square units. Okay. What else? And then they have one here that's kind of, they're trying to trick you. I don't know if we're gonna go like this. It's kind of like the shape went down. Go like that, and like that, and like that. There's still 3 shapes there. Whoops. We still have 3 shapes. Except the one shape is kind of falling down, sort of, right? You can see that? So we have 1, 2, 3, and so like we know for sure we have 3 square units. You just got to be aware that, you know, they try to trick you, they try to stump you, but you just got to be smarter. You know, they're just testing your knowledge, really. They're not trying to see if you're stupid or anything. I'm not saying that at all, guys. It's they're trying to, you know, see it's a test of your knowledge, really. So we can still count the sides. 1, 2, 3, 4, 5, 6, 7, 8. Well, we also have 1 here, 9, 10. So we still have 10 units. Okay. Still have 10 units, guys. That's that. So we're going to carry on to the next page, right? I think for the most part, they're just trying to get you to visualize the different composite shapes. Okay? That's the goal. What else do I have here anyways? Right? Same kind of thing here as well. Okay, we have a composite shape here, right? So you draw an imaginary line here. So now you've taken one shape and turned it into two shapes. Right? Here they're doing the units thing, right? So I don't know. Hopefully it's not too confusing for you guys. I just, calculate the length times the width. Done. I don't know. I mean, if you're subtracting a part of the area out of here, that would make sense. But for an overall shape, I don't see why you would need all these little squares. But that's just me. Okay, they call them units. One side is a unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units. Really, I don't know why it is done that way. The way I would do it, you just count the row, you count the height, and you go 4 times 4. It'll still give you the quantity that's inside. You could count these. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What's faster? 4 times 4. Done. Right? Let me have some coffee here. Okay. All right. It's great to see the world learning math. It's so great. Staying on topic. Staying on topic. All right, let's go. What's next here? Okay, I'm just gonna undo all this. And yeah, I'm just gonna get rid of all of this too. Okay, cleaning it up. Okay, finding an area by counting squares. I just did that too with the example. Okay, so all right, so they're challenging us a little bit. So I'm gonna go 1. Let's see if I could kind of draw. I wish I had the image in front of you, but it's kind of written all over. So, I should almost have just drawn it and scanned it myself. So let me show you something here, okay? We're gonna go. How do we do this? Is that the way the shape's drawn? No. Okay, I'm gonna go like this. I'm gonna actually just draw the shape. Okay, that's why I was like, how am I gonna do this? Okay, I think, is that a rhombus? I'd have to rhombus. No. I guess it's a type of rhombus, right? Yes. Rhombus. Okay, it's kind of like a square that just kind of got crunched. Some car drove into it and squished it. Right? Some car just came in and drove into it because know, they're a bad driver. They need more practice. Okay, pretty good drawing skills, huh, guys? Isn't that amazing? I'm an artist. Okay. All right, let's focus here. Let's see if I could draw that a little bit better. I'm going to try to draw it neater. I'm going to try. Again, I don't have a... I'm using a mouse to do this, so... Whoops. Bit better. Okay, they're not perfect, but it's close enough. So if you actually had a grid, okay, let's say there was a grid here. I don't know. We'll just say it's 5 for closeness. Okay? Ah, it didn't work out. It did not work out. Sorry, I don't have the image in front of me. But if you actually, I mean, I don't have the image. I should have scanned it. It'd be a lot better. Do apologize, guys. Okay, technically speaking, you have a square there, a square there, a square here. Okay. I can go on and on and on. You can see the triangles and the squares that are kind of in there. Just go like that. Okay, I know I messed that up, but you can see it, right? 2 triangles make a square. Okay? So, you could easily calculate the area based on triangles and squares. You just kind of have to match, right? So, so right here, we need to close things up, right? It's not this part that we need to add, though. Because technically we have a square there, a square here. Okay, I know it's terrible. I'm sorry, guys. God, I think I'm gonna scan maybe. I'm not the best at drawers. I'm trying to speed it up so it doesn't take forever either. Okay. So to figure out the area, you kind of have to do this sort of thing. But I'm going to leave it at that. I'm overcomplicating it. I shouldn't have did that one, guys. I should not have done that one. Okay. We're just going to stick to regular shapes. Okay. So what is it? 3. I have to make sure that I draw. I want to try to be at least consistent with the size. many do I need? Honestly, I don't really like drawing in all these units, so it's kind of units, I won't lie, are kind of annoying. Like, I don't know why they're teaching you guys all this extra stuff, which is, I don't know, maybe it's to visualize so that you can visualize shapes within shapes. I guess that's the idea. But if I'm going to calculate the area of a square, 4 lines, 6, 3, 6 times 3, 18, done. Next problem. It took me about 3 seconds. Okay. All right, it's not too bad considering. Okay. So they're showing here a rectangle is a 4-sided figure with 4 right angles. Again, if I scan this, the thing is it's got writing all over it, guys, and you know, it's already been kind of done and worked on, so if it was a clean, fresh sheet of paper, I would have scanned it and shared it with you. Okay, a rectangle is shown on the right. Find the area by counting the squares. Normally, you're not going to have squares inside, right? But this is kind of, I guess, just going to the basics of figuring it out. 1, 2, 3, 4, 5, 6. Okay, we have 6. So normally, I think when I learned, you would just get something like this to the effect. There we go. The number 6. I can't draw a 3 sideways, or can I? I can. Okay. So 1, 2, 3. Right? Normally you're given the numbers. So 6 times 3 equals 18. That's a lot of extra work. I don't know. Again, I'm trying to understand it too, why they teach square units to you guys. I mean, it is what it is, I guess, but like I said earlier, it's probably because of composites. Did I close that image earlier? Hold up. Because of this, composite shapes. They're just trying to get you to be able to figure out composite shapes. Really, that's all it is. That's a lot of extra work for just a simple rectangle, when all you needed to do is just go like this, like that, like that. Put some values here. Something as simple as this, maybe a 90-degree angle. And there you go. And the question could be, what is the area of blah, 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 blah? 6 times 3. It's way simpler. But I guess I kind of understand why they're doing this, but I think it's just a bit overkill. Maybe it confuses you guys too, right? It's just too much. I mean, if it's a shape like this, like a composite, right? I'm trying to do it so that the shapes are the same. And then you have, I have to kind of do it one at a time here. It's just going to be better, right? If you have a shape like that, there you go. Let's say you don't have these lines, okay? Let's say they're not there. So what they're trying to do is get you to figure out the area based on units. Okay, so I guess you would draw a line like this, right? Let's 1, 2, 3. Let's say they had the number 2 there. Let's say they had the number 1 here and the number 3 here, right? You can figure out this area. You have 2 plus 1, right? So you can figure out the overall length. There's nothing wrong with you drawing your own dimensions and going like that. Okay, it's 3 by 3. So, but you can calculate the area of this one and then calculate the area of this one. Right? So this one would be 1 times 3. And this one here, well, obviously this is most likely the same. Then you would go 1 times 2. So this would be 2 square units. This one will be 3 square units. So 2 plus 3, which gives us 5. Does that work out? Yeah, I guess it would. Square units, right? 1 times 2. 2 square units. 1 times 3. 3 square units. 2 plus 3 equals 5. 5 square units. Okay, you kind of get what I'm putting down there a little bit. Hope so. For a shape as simple as this, you don't need all that because it's pretty obvious. But the idea is just to get you used to, you know, you could count them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, right? You could keep counting them all, but it's a lot easier just to go count the rows and then count the columns. So how many are in the row? 1, 2, 3, 4, 5, 6. How many are in the column? 1, 2, 3. It's as simple as going 6 times 3, and you don't have to count them all. It's so much quicker. Okay, trying to lessen the confusion is what I'm trying to do, guys. I know my drawings aren't perfect, but I'm trying. They're getting a little better. Okay. Again, I almost wish I had these scanned, but I don't. Okay, and they're kind of doing the same thing with a triangle. 1, 2, 3, 4, 5, 6. 1, 2, 3. There's the middle. 1, 2, 3. And there we go. I'm just going to connect that. Try to. Okay, there we go. Not too bad. Okay, now I could draw a square here. I could. But if you really think about it, just like I said, remember, guys, it takes 2 triangles to make a square, right? So let me draw a square. Honestly, I just want to get to doing the math problems. So if you look, if I connect this, you see? 2 triangles. This would be triangle 1, and this would be triangle 2. Takes 2 triangles to make a square. So really, I could just turn this triangle into one square, just calculate the area. So I didn't draw the units because that's just it's too messy and also too confusing. So I'm avoiding that. So we're given 6. And I'm just going to say it's the same height. And 3. Okay. That's a 3 turned sideways. Okay. Same thing, guys. So literally I could go, because this is going to be the same. So I turned this triangle into a square. You should get the same result. Right? You do. You know why? Because if you calculate the area of a triangle, it's half of it. Okay? So I could go 3 squared equals 9. Okay? That's the area of our square. Okay? So take this side here and just go flip it and put it on top, kind of like you see here. Turn it into a square, calculate the area, and that's it, right? So you'd be done. This would give you the correct answer. This is the correct answer. You know why? Because the area of a triangle is the base it's 1/2 base times height. Okay, I didn't show you the formula. Do I have the formula in front of me here? Why do I keep closing that picture? Let's see. Okay, triangle. It's 1/2 the base times height. Okay, so if I substituted, the base is 3, the height is 3, but it's 9 divided by 2. Okay, so the area is going to be 9/2 for one triangle. Okay, so if I go 9/2 times 2, well, it's the same thing. It's just like we were doing math before. This is a numerator. So the 2's cancel. You're left with 9. I can show you the work, I guess, too, but when you're working with fractions, it's great because it's straight multiply the numerators, straight multiply the denominators. So you get 9 times 2 is 18. 2 times 1 is 2, which equals 9. Okay, that's why it's half, right? Because it's half a square. So that's why the area of a triangle is 1/2. Okay? Make sense? I hope so. One half. All right, how are we doing for time? That's long enough. That's definitely long enough. Okay, hopefully that wasn't too painful for you guys. Trying to make it like easier to understand, and plus why the formulas are the way they are. I mean, it doesn't really matter how you figure it out. as long as you get the right answer in the end. Again, you can calculate the area of triangle 1, calculate the area of triangle 2, and do what I did here. Or you could just turn it into a rectangle and go 3 times 3. Done. Way faster, right? Isn't it? But you have to have 2 triangles, and they have to be exactly the same shape. Exactly the same dimensions is what I'm getting at. Way quicker to calculate the area of a square. Okay? Or a rectangle, because technically 2 triangles can make a rectangle as well. Alright guys, I'm leaving it at that. Hopefully we get on to something better, because I just want to crunch out numbers. And that is it. Thank you for watching, and we'll see you guys in the next video. Appreciate you. Take care.